Hello and welcome to our video that will cover the notes for lesson 12.5. This video is going to be a little bit different. Pay real close attention at the beginning. We're going to look at some interesting pieces as to how we get the volume formulas for pyramids and cones. And so we're going to examine this with a little bit different style of video. I'm not going to have you writing things down just yet. We're just watching the video, paying attention, and then at the end of the video is when we'll actually take a look at some of the notes. So first of all, I want you to remember this. The volume of a prism is equal to the base area, or area of the base of that prism, times the height. So if I had this prism, you'll see we would call this a pentagonal prism. The volume would be the area of one pentagon times the height of the prism. So here's what I want us to think about. What would the volume of a pyramid be of those same dimensions? Okay, where my pyramid is the same base size and shape and same height as the prism, but it's a pyramid instead of a prism. So we're going to look at that by answering this question. How many times can the pyramid fill the prism of those same dimensions? So we're going to illustrate that with some colored liquid that can best represent our volume. So I want you to take a guess here and write down on your notes how many times you think this amount will fill this amount. Alright, and let's see what we get. I'm going to try my best to fill this to the very top without overflowing. Okay, so there's one. Let's try it again, because we're not quite full yet. Ooh, got it real full that time. There's two, so it's more than two. And there's three, and actually that first one was a little bit less, and so it would actually have filled right up to there. So how many pyramids did it take to fill the prism? 3. And so we should be able to help understand what the volume formula for a pyramid is based on the volume of a prism. The prism was base area times height. It took 3 of these pyramids of the same base area and height of the prism to get that area. So the volume of a pyramid of those dimensions would be 1 of these out of a total 3, or 1/3 the base area times the height of your pyramid. Alright, the same kind of thing is going to work out with cones. Okay, but we want to test this out. I'm going to try and put this all back together and show you how it works for cylinders and cones. So let's take a look at cylinders, and remember that the volume of a cylinder is pi r squared, which would be the area of a base, times the height of the cylinder, the distance between those bases. Now, we want to then figure out what the volume of a cone would be with the same circular base and the same height. Okay, you can see those are the same. Alright, now for pyramids and cones in this lesson, notice we're just using actual height. I'm not using slant height like surface area did, because I'm not talking about the surface on the outside. I'm talking about how much space is taken up. So again, I'm going back to using the height measurement. Alright, so if I have one cone that is the same base area and height as its corresponding cylinder, we again want to ask ourselves this question. How many times can one cone fill the cylinder of the same dimensions? So let's try that. One, and this is going to be a little harder to pour. Two, again trying to be careful. And let's see if a third one will top it off. right up to the top. So again, we had 3 cones that filled up one cylinder as long as they have the same dimensions, same base area, same height. So if it took 3 of these to fill this, that means this volume, the amount of liquid or amount of substance that would fit in one of these, has to be 1 out of 3 total that fill this shape. So once again, how many times can we fill it? 3. That means that our volume of a cone formula is 1/3 the volume of the cylinder, pi r squared h. Remember, we're talking about the actual height from the top down to the bottom, or if you're talking about it this way, from the top down to the bottom. All right, the next part of the notes we'll actually take a look at using those formulas to solve some problems. All right, let's take a look. Here's our formula again for the volume of a pyramid. 1/3 the area of the base of the pyramid times the height of the pyramid. Notice we are using the actual height, not slant height. This is true no matter whether it is a right pyramid or a non-right pyramid, meaning if this point is not offset from the center of your base, or you can think about it this way. In a right pyramid, all the lateral face triangles are congruent triangles. In a non-right pyramid, the lateral faces will not all be congruent triangles. They'll have different angle measures. And so, it's true the volume formula works for either one of these no matter what shape you're taking because of Cavalieri's principle. So, in order to find the volume, those are the measurements we need. We need to know the area of the base, we need to know the height. So in example 1a, we have a height of our pyramid of 7 inches, and this square at the bottom has side lengths of 3 inches. So all you have to do to find your volume is plug those values into this formula. But remember, your formula is 1/3 of that base area times the height. So that will be very important. So the base area is 3 squared. The height is 7. So the base area is 9. So we're going to do 1/3 of 9 times 7. I'll come down here. That's 1/3 of 63 if you want to think of it that way. Or you could do 1/3 of 9, which is 3, and then multiply by 7. Either way, we get an area, or I'm sorry, a volume of 27 cubic inches. All right, why don't you try part B using that formula again, 1/3 base area times height. Try part B on your own and come up with an answer, and if you need time, pause the video. All right, make sure you pause the video if you need more time to work this out. Otherwise, this is what we should get. A base area of 64 square feet and a height of 6.5. So when we plug those into our formula and do that calculation, we get 138.6 repeating, which is about 138.7 cubic feet. Now, if you're struggling with how to enter that in the calculator, remember 1/3 is the same as dividing by 3. So if I did this, that's the same as that. And so it might make more sense to multiply these two and then just divide by 3 when you're doing your calculations. Alright, let's take a look at what we know about cones. We discovered those formulas as well. The volume of a cone is equal to still 1/3 base area times height, but base area is pi r squared. So our volume formula for a cone is 1/3 pi r squared times h. And again, it doesn't matter whether it is right, or we can often call this oblique or non-right cone. The height, though, in an oblique cone or a non-right cone will be an exterior measurement usually. Alright, so let's go ahead and take a look at these examples. In example 2a, we want to find the volume of the cone, and so we need to know the radius and the height. They've given me both of those. R equals 5, height equals 12. So we're just plugging those into this formula. 1/3, don't forget that part, it's very important, pi times a radius of 5 squared times my height of 12. Or we could do that pi times 5 squared times 12 all over 3 like that. Either way we do that, we're just going to simply put that through our calculator and round our answer to the nearest tenth. And when I put that in the calculator, this is what I should get. About 314.2 cubic inches. Now, I will tell you, we can go through and do some more calculations on paper. 25 times 12 is 300, but we could do the divided by 3 part first. Remember, you're not dividing 300 and pi by 3. We're not adding those two. We are simply dividing one or the other by 3. And so I could divide the 300 by 3 and get 100 pi, which explains why it looks a lot like the digits of pi, 3.14. The next digits before we rounded were 1, 5. That's because 100 times pi just moves the decimal 2 places. All right, last example. Why don't you go ahead and try this one on your own, and when you think you have an answer, continue watching the video to check that answer. All right, pause the video if you need more time. Otherwise, this is what we should get. About 2,168.0 cubic feet. That's actually 2,167.96, but that makes me round it up to 2,168. If you're getting different answers on these, you could be making a calculator error. Remember to go back to your order of operations. Take the radius value and square it first. Go ahead and hit enter. Then multiply by 25. Then multiply by pi. Then divide by 3. Or multiply these two, divide by 3, then multiply by pi. But you might be making a calculator error. If you're still having trouble with that, you can ask me about it in class. All right, and that wraps up our notes on volume, and so we will begin that assignment in class on block day.